Okay, this is an example of function notation, evaluating a function at different inputs. We're going to evaluate our function f at x at f at 1 plus h. So I'm going to do that first. So I have to put in for any x the input of 1 plus h. So it's 1 plus h squared minus 2 times. I got another x, so I have to put in 1 plus h. So I'm going to evaluate this. This 1, we square a binomial, you get a trinomial. So square the 1 is 1. Multiply those two together, so plus 1h doubled is 2h, then square the last, which is going to be plus h squared. Then I got to distribute the negative 2, so negative 2 minus 2h. So this is what f at 1 plus h is equivalent to. So that's at least a part of mine. So I'm going to simplify it a little bit further and put it in standard form. So it's h squared. I can collect this like term with this like term. They cancel. And it's going to collect our 1 with the negative 2, and that's going to be minus 1. So in simplest form, f at 1 plus h is h squared minus 1. I want to keep that in mind because that's going to go back up into our original expression up here. Next thing I'm going to do is I'm going to find the value of f at 1. We have to get the value of f at 1, so that means I put a 1 and square it minus 2 times 1. That's a 1 minus a 2, which ends up being a negative 1. So f at 1 is a negative 1. This is going to be represented in this format, and then our h. So with h, we don't have to do anything with that. That's just part of our expression that we're going to simplify. So putting this stuff into play. Find f at 1 plus h. Well, that was h squared minus 1. We're supposed to subtract from that the value that we got at f at 1. Well, the value of f at 1 was a negative 1, and that's all divided by h. So we're going to simplify up on top here. Minus a negative is plus, so it's h squared minus 1 plus 1 all over h, which if we simplify further is h squared divided by h, since these collect to give you 0. And then if we finish that off, that is simply just h, because h we're going to h squared once, so with one of those left over. So in the end, all we get is our value of h.